Alright, 3.2 Intercepts. Let's see what it's about. If you go to page 98, example 3.2a gives us a list of points to put on a graph or a plane. Let's take a look at what happens when we graph them. So here we have it. I made it nice and color coordinated. So we got 0, 3 in blue, 3, 0 green, 0, -3 in yellow, and -3, 0 in red. What's special about all these points? They're all on the black line. Yes. So all 4 of these points fall on one of our axes. Axes is the plural of axis. It's not axes. It's axes. I just did it wrong. Wait, did I? Axes. Axes is the plural. Alright, so what's special about all these points? Let's take a look back at our ordered pair. All of our ordered pairs have a 0 in them. If we look at our red and green points both fall on our x-axis, and they both have a y value of 0. That's because if we start and we go to 3 to the right, and then we look at how many we go up and down. We go 0 up and down, which means we kind of just sit on the line, and the same over here. We go to -3. The 0 tells us we don't go up or down, so we just sit on the line. And then it's the reverse is true for the y-axis. Our yellow and blue. Yellow and blue, I did this color backwards. 0 is in the x spot, because when we start, we go, how many left to right do we go? We go 0. And then the second number tells us how much up or down we go, which means we're just sitting on the axis again. So for the x-axis, if we have a 0 on the y-coordinate, we know we're going to be sitting on the x-axis. If we have a 0 on the x-coordinate, we know we're going to be sitting on the y-coordinate. It's a little flipped. But it's called the intercept because that's where that point crosses one of our axes, or it touches. It makes more sense once we graph a line why it's called an intercept, but for now, just know that wherever the point touches our axis, and wherever we have a 0 in our ordered pair, that's where our intercept is. So that leads us to the question, if we have an equation, how can we figure out what the intercepts are? Because some lines will have 1 intercept, some lines will have 2 intercepts, some lines might have 0, but they wouldn't be lines anymore, but we'll talk about that later. Anyway, how can we tell from an equation what our intercepts are? So remember, our x-intercept means that our y value is going to equal 0. Our y-intercept means that our x value is going to equal 0. So this tells us that if we want our x-intercept, we just make our y 0. So let's do that. Let's substitute our y with 0, rewrite everything else, and let's solve for x. Get x by itself, we subtract 3, we subtract 3. That gives us -3 equals x. So our x-intercept for this equation is x equals -3. What if we wanted our y-intercept? Well, our y-intercept says that our x is going to equal 0, so let's do substitution over here. Oops. So we'll say y equals 0 plus 3. Simplify, y equals 3. So this tells us that our x-intercept is y equals 3. It's a little backwards, right? X equals -3 is our y-intercept, and then y equals 3 is our x-intercept, because that's where our x equals 0, and that's where our y equals 0. But yeah, the point is, if we want to find the intercept, we just set each of them equal to 0 and solve separately. We set y equal to 0 and solved. We set x equal to 0 and solved for the other variable. All right, let's do example 3.2b. It says find the x and y intercepts of the equation and graph the line. So here we have our equation. Notice that it's written differently from the others. In all the others, we had y by itself. Y doesn't have to be by itself. Remember, equation just means there's an equal sign, and the ones we're working with for graphs are going to have 2 variables. We still have 2 variables, so it's fine. So the first thing it says to do, find the intercepts. So if we want to find the x-intercept, we set y equal to 0. So let's do some substitution. Let's solve for x. X plus 0 equals 6. X plus 6, that equals our y-intercept. And then if we want to find our x-intercept, we set x equal to 0. It's 3y equals 6. 3y equals 6. Get y by itself. Y equals 2 is our x-intercept. So this tells us that we cross our y-axis at x equals 6. So let's graph it over here. We'll count by 2s. 2, 4, 6. 2, 4, 6. And then we got negatives in the other direction. So our x-intercept, or our y-intercept, so y-axis, is x equal to 0. Oh, which was paused, which wasn't? I don't know, I'm confused. And let's take a look at 3.2c. It gives us the equation x plus 3y equals 0. And the same thing, it wants us to find our intercepts and then graph the equation. So first, let's start by finding our x-intercept and set y equal to 0. So x plus 0 equals 0, x equals 0. So we know that x equals 0, and we already set y equal to 0 right here, so our point is 0, 0. So we graph the point 0, 0 right here. That's also called what? The origin. And then let's do the same over here. Let's set x equal to 0 to find our y-intercept. 3y equals 0, divide by 3, y equals 0, so we have the point 0, 0 again. Uh-oh, that's the origin. We can't draw a line without a 2 points. What happened here? So because we had a line going through the origin, so let's imagine I draw a line here. See how if a line passes through the middle, it's only going to pass through the middle, and it's not going to cross through two of our intercepts like all the other times. So because we're crossing directly through the middle, we actually need to come up with another point. How do we come up with another point? Just plug in a random, just plug in usually one, not a random. Ones are usually easier. But we'll plug in 1 and see what it gets us. So replace x with 1 plus 3y equals 0. Solve for y. We got 1 plus 3y equals 0. Subtract 1, subtract 1. 3y equals -1. Divide by 3. Y equals -1 over 3. So that gives us, we plugged in 1 for x, so that means our first coordinate is 1, and then we got -1 over 3 for y. It means our second coordinate is -1 over 3, so we can graph that. This is 1, and this is probably -1 over 3 right there. Just a guesstimate. So we got our 2 points, and now we can draw a line. So sometimes this is an example of a line that only has one intercept. It's technically the x and y intercept, but when it crosses through the middle, it's obviously a special case. So when that happens, we just need to plug in another random value and see what points that gives us so we can finish the graph. And then our arrows to let us know our line continues. All right, that's about it. It's basically just plugging in zeros to find our intercepts. Intercepts are special because that's where we cross our axes. Yep, see you in the practice video.